Increasing photovoltaic installation globally has increased the demand for innovative, accurate and user-friendly tools. It is often difficult for beginners to use traditional PV sizing software and complex calculations. Therefore, this project introduced an interactive online sizing framework for grid-connected photovoltaic system, a web-based application developed using Python and deployed via GitHub and Streamlit Cloud. Problem statement: sizing PV manually is time-consuming and prone to human error, especially when adjusting for performance factor and temperature tolerance. Currently, most PV sizing tools require advanced engineering knowledge and paid subscription. There are no user-friendly online platforms that allow quick comparison of PV module configuration. It is often difficult to determine the best orientation of module. The objective for this project is to develop an interactive online dashboard that can perform PV sizing calculation automatically based on user input. Next, to assist users to determine the optimal number of PV modules that can be installed on specific site. Lastly, to provide the accurate performance estimation, power output, yearly energy in a suitable format for beginner and professional. The unit of this system is PV performance equation are complete instantly without showing complex formula to the user. The system automatically compare landscape and portrait orientation and identify the best orientation that got the highest number of installable modules. No installation required, works on any device via browser. The dashboard includes a welcoming interface, fixed background, structure style and clean layout. Using Python, Streamlit and GitHub, we can provide an easy entry tool for PV system. We can contribute to the national and global carbon reduction goal. The community can adopt with solar energy. Lastly, we can increase the green technology sector. For the commercial potential, we can add more features like cost estimation, inverter sizing and so on. The university, training center and solar company can customize this system with their branding. We can offer the analysis, data storage and PDF report to the professional user. We can expand this system with prediction maintenance, panel performance tracking, and smart solar monitoring. Hi everyone, this is the photovoltaic system. As you can see, this is the user interface for our dashboard. How to use this dashboard? We just click the start button. Then we can start design our photovoltaic. Okay, for the first step, we can determine how much the power output from the chosen PV module by consider all the temperature factor. Usually, for the temperature factor is same for all the panel. So, we just key in our module properties that we refer by the datasheet. Panel length, panel width and the rated power. Then we can see the result that calculate automatically by this dashboard. You can see the panel area and the power output from the PV module and also the prediction of the yearly energy by consider 4 hours per day of the peak side. Then for the next step, we go to the architecture constraint. Here, we can determine how much the PV module that we can install for the certain site. So here we just key in the width of the site, length of the site and also the width of the module and length of the module. Then we can see the result, how much the total PV module that can we install in landscape orientation. Also, we can see how much the PV module can install in portrait orientation. So then for the last step, the dashboard, we recommend the best of the orientation. Here we can see the best of the orientation that we can maximum use the site that we choose, which is portrait orientation. Then for the last, then this dashboard can show the final system performance. So we can see how much the total peak power output that we will get from our design. Then lastly, we can predict how much the total yearly energy that can generate by our design using this dashboard.